Hey everybody, in this video we're going to learn about how to find the voltage drops across resistors in a circuit. Now this is done a little bit differently for series circuits than it is for parallel circuits, so I'm going to start by going over the rules for each one. In a parallel circuit, the voltage across the battery is the same as the voltage across the resistor. So no matter how many resistors you have, as long as they're all wired in parallel, each one of them will get the same voltage as the battery has. In a series circuit, voltages across each resistor added together equal the voltage of the battery. So you have to take all of the voltages that you have and add them up, and then only when you put them all together will you have something that equals the voltage of the battery. So I'm actually going to start by going over this for a parallel circuit, because it's actually easier to do this for parallel than it is for series, because in a parallel each resistor just gets the same voltage as the battery each time. So let's say I have a 12-volt battery. So there's 12 volts in my battery here. Each resistor just gets 12 volts. So looks pretty simple, right? Let me try it for, let's say, 5 bulbs in parallel. Sounds a little complicated when you first hear it, but it's exactly the same thing as it is for 2. Each resistor still gets the same voltage as the battery, and I can just write the voltages in right next to the resistors here to show that. So no matter how many resistors you have, even if I added in 3 more or 5 more or 10 more, they would each get the same voltage as the battery. In this case, it's 12 volts. Now I'm going to go over this for a series circuit. So just bear with me here while I draw up a new circuit. So I have my 2 light bulbs wired in series here. Let's say that I have a 12-volt battery again. And in this case, we need to do something a little differently. Now, we're going to assume that these resistors are identical, that they have the same resistance. And when you have that, you can do something kind of cool, which will make it very easy to calculate the voltage drops. So in this case, you're going to take the voltage of the battery, and you're going to divide that by the number of resistors in the circuit. So if I have 2 resistors, then I'm going to take my voltage of the battery, which is 12, and divide that by 2, which is the number of resistors I have, to get 6 volts across each resistor. So once again, take the voltage of the battery, divide it by the number of resistors you have, and you'll get the voltage that goes through each resistor. This only works when the resistors are identical. In your house, if you're using the materials that I provide for you, my light bulbs, you will have this situation, and you can use this exact method to find your voltage drops. If you're bringing in your own materials from home, you're going to have to do something a little different. So just come see me and we can work through that together, and I'll help you figure that out. Moving forward with this example, let's say that I add in a 3rd resistor to this circuit. So now, instead of 2, the number of resistors that I have is 3. We're going to use the same method, but this time the voltage is going to be a little bit different. I still have the same battery voltage, so this is going to stay 12 on top of this fraction here. Then I'm going to put 3 on the bottom, because 3 is the number of bulbs I have, or resistors that I have in this case. And I'm going to get 4 volts. So that means that each resistor in the circuit has a 4-volt voltage drop across it. So maybe you can start to see as we're going through this that the more resistors you add, the less voltage you have across each one. Whereas in a parallel circuit, the voltage across each light bulb won't change. It'll just be the voltage of the battery, even if you keep adding on more bulbs in parallel. So now we're going to transition from talking about voltage drops to figuring out how to calculate the power through your light bulbs, or resistors in this case, in your circuit. So now we're going to focus on learning how to calculate the power that's given off by each resistor in a circuit. I'm going to start by just giving you some of the basics of what you need to know in order to make this calculation. So in my table here, I have written in 3 important electrical quantities, which are voltage, resistance, and power. I've also written in the columns of this table the symbols that are used to represent each of these in an equation, as well as the units that go with each of them. Now, units are basically a way of showing how much of something you have. It's a way of representing the amount of something. So I'm going to start with voltage. In this case, I use a capital V as my symbol, and capital versus lowercase does matter here. You need to make sure that you're capitalizing all of the symbols shown in this table. Volts is the unit that goes with voltage, and I can abbreviate that with a letter V by writing the letter V right next to my number to show that volts is the unit that goes with that number. For resistance, I use a capital R as my symbol, ohms as my unit, and I can use this weird symbol here, which is the Greek letter omega, to abbreviate that unit. For power, symbol is capital P, unit is watts, and abbreviation is the letter W. Now I'm going to talk a little bit about the equation, which is how we connect all of these things together to use one to help find the other. My equation is P equals V squared over R, or P equals V squared divided by R. Another way to say that is that the power equals the voltage times the voltage, so the voltage value times itself, the same number, divided by resistance. Now I'm going to show you how to take this equation and use it to calculate the power through resistors on an actual circuit. So in this series circuit here, I have an 8-volt battery, a 4-volt voltage drop across one resistor, and a 2-ohm resistance across one resistor. And the voltage drop and the resistance are exactly the same for the second resistor here. So 4 volts for the drop, 2 ohms for the resistance. I'm only going to calculate the power across the resistor that I have circled here. So I don't have to worry about this 8-volt battery voltage. I only have to worry about the 4 volts for this resistor and the 2 ohms for this resistor. To solve for the power, I'm going to use something called the guess method. And the way that it starts is by finding the givens in your problem. So those are the things that you already know before you start trying to solve for something. In this case, I know the voltage drop and the resistance, so I'm going to write those in as my givens. So for the voltage drop, which is 4 volts, I will write V equals 4 and then V to abbreviate the unit. For the resistance, I write capital R equals 2 and then the symbol omega for ohms. For my unknown, I have to find the thing that I don't know yet in the problem, the thing that I'm trying to find. That's my goal, to know what it is. In this case, that's power. So I'm going to write in P equals a question mark. And I'm writing this in to remind myself of which symbol I need to look for when I'm choosing an equation. In this case, the equation is given to us already, so I'm going to write that in. P equals V squared over R. And now I need to substitute my givens into the equation. So I need to take the things that I already know and put them into this equation for the substitute step. I'm going to start by just writing the letter P because I don't know what that is yet, so that's still going to remain a letter in the equation. I know what V and R, what values those have, so I'm going to take those numbers, put them into the equation. So for V, my voltage is 4, so I'll write 4 squared, P equals 4 squared, divided by the R value, which is 2. Now, to solve it, I just need to take this expression that I have and simplify it. So I'm going to start by writing this out as P equals 4 times 4 divided by 2. Now, if you are uncomfortable with just doing the math by hand, you can use a calculator, but if you want to show your work on paper, that's totally fine too. So in this case, 4 times 4 is 16, so I'm going to write it out again as P equals 16 divided by 2. And then I just need to simplify it one more time. So I take 16 divided by 2, that gives me 8. So P equals 8, and I use the letter W to abbreviate watts. So that is how you calculate the power that's given off by a resistor in the circuit. If you know what the voltage drop is, it's exactly the same for series and parallel circuits. All of these steps are the same. The only difference is finding the voltage drop, which we just went over in the beginning of this video. So if you know how to find the voltage drop across a series and a parallel circuit, you should be good.